what I can do here is just change some of these things. I can say, okay, what if it's 300 bacteria and it triples every 2 hours. I mean, the thing is it's only going to, if you already know the answers to the previous one, you're just going to know how to change the answers. So it's not necessarily the best way, but why don't you try coming up with the equation for this, please?
N equals 300, and then in parentheses 3 to the power of 12x.
Sorry, I didn't, that is correct. What is the next problem that you want us to look at?
11.
11, all right.
Some of these are just like concepts I need to review, but then like other ones are.
Okay, so the range is based on a lot of things that are going on here. Basically, you have to know the parent function here and what this looks like. So the parent function looks like a quadratic, even though it's a fourth. X to the n, where n is even, always has this sort of shape to it when there's only that one term there. But then you need to know, what does the other stuff do? Well, the negative flips it, and the +7 jumps it up. So it ends up looking like this. Okay, so the range is always the min to the max. Sometimes students like bottom to top, something like that. And they're using this inequality notation, which suggests that there's like a place where it does stuff. So the peak here, the peak at the top here is 0,7. And the range is y less than or equal to 7, because it's all the values below that.
Okay, and then it's 7 because the +7, and
Yes.
it's less than 7 because of the negative.
Because it's opening down, right? So we got to be careful here, because like there's, if I make one change to this, which is -2x cubed plus 7, the answer becomes D.
Okay.
But if I change it to -2x to the, I'm sorry, if I make it 2x to the 4th plus 7, the answer becomes B. And so what this question is really testing is your knowledge of odd and even functions. I'm sorry, odd and even exponents, and then the leading coefficient. So
How would it be B?
for this one, it would, because the graph would be, it would look something like this for B.
Okay.
So there's 4 graphs you have to know to be able to answer these. And so if it's an even power, it starts high and ends high, or it starts low and ends low. And this is a greater than 0. This is a less than 0. And so a is the leading coefficient. So that's what this problem is really testing. It's like, do you know the 4 graphs? And here's 2 of them.
Okay.
Now for the odd ones, so when I'm again, I send these notes at the end, but for the odd powers, it starts low and ends high, starts high and ends low. A greater than 0, A less than 0 for the odd powers.
Then that would just be like a straight line.
No. Like think of an x cube or an x to the 5th or an x to the 7th. Like it can do a lot of things in between here. Oh, why did it do that? And then the other one, like it could just kind of curve like that. The point is that it can do a lot of things in between. The ones
Okay.
up here, though, similarly, like they could do a lot of stuff. I don't know why that is happening. That's really weird. Or they could just do that, that is a possibility. The idea, though, is you don't actually care what's going on between, you only care about what's called the end behavior. But in terms of the
Yeah.
range, you need to know, if it's bounded above or bounded, well, in this case, there's no, this one bounded below. So that's really what these are testing. So let me give you another function here. Let me give you, let's say f of x equals 5 minus 2x squared. And it asks for what is the range. So this one I actually can do A, B, C, D. So y less than or equal to 5, y greater than or equal to 5, y less than or equal to 2, like that. Okay. So those are your possibilities for this one.
Um, it would be A, right?
What's the next question you want us to look at tonight?
15.
15. Now, is your diagnostic or test, is it multiple choice like this, or is it?
I'm assuming it's multiple choice.
Yeah, so I mean, reason I ask here is like, for example, and this is a test taking strategy, is like you could try the answers. Now, your decision to try the answers is based on something like the following: how many places you have to try the answers, if there's any overlap in the answer space, which there is none. So that would lead you to like, this is probably not a good strategy on this problem, because let's just say you chose 5, try 5. Well, 5 doesn't appear anywhere else. So if it worked, then you've got it. If it doesn't work, it just tells you it's one of these other ones. You also have issues where you're trying fractions. That's not always great. There is a one answer you can eliminate right away, because it tells you that x cannot be -2 and x cannot be 3/2. You can eliminate that one right there, because they're saying like, no, it can't be those values. All right, but that may or may not, jump out to you. So now if you want to try the answers, you're only down to, you could try like 5. If that didn't work, you could try 2. Or you could solve it directly. You can use the direct method, which is what they would teach in the classroom. So how would you solve something like this?
You would substitute the first number and then you substitute the second number to see if you get the same answer.
No. See, that's the mistake here. Is like, you only have to try it since if 3 works, you're done, because the 3 doesn't appear anywhere else in this list.
Okay.
Like, I know the tendencies are, well, you're gonna try them both to make sure, but if 3 works and 3 doesn't appear anywhere else, then you got it. But if 3 doesn't work, you just cross it out and then you try 2. So I guess that's what I'm asking.
So it would be A.
Did you try it or you're just,
Like I substituted 3 in.
okay, and it works, right?
Mhm.
So there you go. Okay, now the direct method is to cross multiply. So 5 times 2x minus 3 equals x plus 2 times x. Problem with this is that you have to solve a quadratic, which again might lead you back to testing the solutions. That's why I asked if you could do that. So the tendency in problems like this is to give overlapping answers. Like a more traditional answer space would be something like this, where it's like 3, 5, 5, -2, -2, 3, and then I don't know, something else. But the point is, like, if you try 3 and it worked, let's go -5, negative or +2. So if you try 3 and it works, all that tells you is you're down to A or C. If you try 5 and it doesn't work, that just means you can only eliminate A and B. You still get, like, it doesn't necessarily help you figure out stuff. If you try direct solve, you get you get a quadratic that you have to solve, which could be really time consuming.
Mhm.
So let me find a few more of these. Um, um, I can probably convert these to a multiple choice. So let me see if I can. That's one of the challenges. These are hard to come up with on the fly. None of those are working. I'll look at one more resource. Yeah, I mean the more common one. C7. Okay. The more common question that you would get is something like this. And then the answers would be like -1, 0, 1, 2, something like that. And you can try this one for us now. It's not the best example, but it does illustrate what we're trying to accomplish here. So if you want to give that a try, please.
C.
It is C, yeah. Let's go back to this one for a moment. If you were to try to solve it on the right side, you get x squared plus 2x. On the left, you'd get 10x minus 15. And so you'd move right because you want to keep the x squared positive. So you'd end up getting x squared minus 8x plus 15, and you would have to factor this. That's not too bad, but it's just that you you run the risk of choosing the wrong numbers. Like, let's just say you get x minus 3, x minus 5. Well, it's easy to put -3 and -5. You got to carry it all the way through. X minus 3 equals 0, x minus 5 equals 0.
Okay.
All right. Could maybe find another one, or we can just go with that.
Is there any way they'd like complicate these problems or something?
Yes, I mean I can make them we can make them way more complicated. They're just not going to be multiple choice.
Okay.
Um, which I mean I think is a good thing, but I don't know if that's the direction you want to go. Like I found that's easy. It's easy to go more difficult. They're not going to be multiple choice. Multiple choice requires a lot of things to work out. So this one should say that y cannot equal 3. And this one does potentially require you to do something. There's a little trick here if you want, but what do you see when you look at something like this?
They have the same denominator.
Yes. That is helpful.
But if you got rid of the denominator and then did +1 on each side, it would be y equals 3, but it says y doesn't equal 3.
That's right. That's right. So this is what I meant by these are more difficult. These are the ones where you have to, what does that mean? Or what does it mean if you get a solution, but it's excluded from the domain? Can it still be a solution? The answer is no. So this has no solution.
Oh, okay.
That's like one of those little wrinkles that you wouldn't know unless you had seen this before.
Mhm.
Okay, so you're looking for more difficult questions here. I sell a book of more difficult questions that was way too difficult, and most students didn't never like this. But let me see if I can find what you're looking for here really quickly.
Okay.
Where are all the tools? These are gonna appear later, and those aren't they? Yep. So these are kind of in the same category of question. We'll just throw one up and see if you what you think of it. There is always kind of a trick, a shortcut, but you want to give this a try, please?
I got -4x over -19 over 6x plus 12 over 19.
Yeah, but none of those are here. The numerical value is
Yeah, I don't know how to like simplify it from that.
okay. Yeah, so that's it's kind of related to what we're doing, but I'm guessing you put in these values for a K and M.
Mhm.
Okay, so one option is to straight substitute in for 19y, or sorry, for y, right? And that's kind of what I heard there. And then that creates this awful mess, but it does work. It's just really bad. The other thing here is to do a little bit of manipulation. So if you kind of just move some things around, 6y equals -x, you're like, why would you do that? Because you don't always just substitute in for a variable. You sometimes substitute in for a multiple of a variable. So if you wanted to get to -4, you multiply both sides by 4, and you get -4x equals 24y. So -4x is 24y over 19y plus 12 over 19. The y's cancel, and you end up getting 36 over 19. All right.
How'd
let's
you,
look.
I don't get how you got the minus 4x equals 24y.
You multiply both sides by 4. Negative x times 4 is negative 4x. 4 times 6 is 24y. And there you have it. So what's uncomfortable, but this is a test taking strategy, and a thing you want to learn is you don't always substitute in for x. You substitute in for multiples of x. And that is, something to learn because you're so used to solving for the variable, but that's not what is needed in this case.
Okay.
I would recommend we just go back to working on some of your problems. I mean, it just some of these are hard to make up on the fly. But you said what did you say after 15?
17.
17. Okay. All right. If the function f of x equals a times x plus 2, x minus 3b, a and b are both integer constants, and b is positive. So b is positive. That means it's like a 1, 2, 3, 4, 5, 6, 7. If the end behavior of the graph is positive for both very large value and very large negative values, that's what this means. That's positive. That's the positive right there. Okay. What is true about A and B? Okay. So the thing is here, it's easier to look, well, it's easier, I guess, to look at A. We already talked about this. A has to be positive for this to happen because positive A is going to multiply whatever this is right here. And it's just got to be positive. If it were negative, they would both open down. So that gets rid of 2 answers. All right. Now, what's called the power term. The power term is what happens when you like whatever B is, like, let's just say for simplicity, B is 1, and then you FOIL this. It's the X times the X. That's the power term. But if B is like 7, it's whatever that is, which ends up being X to the 7th times X. So your power term is actually 1 plus B. And the only way you get this behavior here is if it's an even exponent, which means that B is odd. A lot of this kind of back and forth stuff. Where it's like,
Okay.
well, the whole thing is even, but B has to be odd to make that even.
Mm-hmm.
There you have it.
Okay. And if it was even, it would end on the bottom right.
If the whole whole thing was odd, it would either start low and end high or start high and end low. That's the 4 graphs that I was showing you earlier. Like you have to know these 4 graphs. Odd powers. So the even powers are like x squared, x to the 4th, x to the 6th, and so on.
Okay.
Let me look up some end behavior problems here. So let me snip in a few of these. All right, so just kind of like worksheet practice here. If I give you the function, you have to know what does the graph look like, and what you really care about is like what's happening left and right. Like, and again, there's those four graphs. Let me see if I can just grab the 4n behavior graph. See if I can find an image of that. Because what I'll do is I'll just snip them in. And then, well, that one doesn't. All right, so let me. So this is a nice picture. Let me. Just found this on the web. Like this is what you're trying to remember. Right here. And so the question is, I'll just label these A, C, and D. You know, which one is this? Which one is this first one here? So grab it. A, B, C, or D.
A.
It's A. Okay. And so that's what the that's what those problems are trying to test you on. Now let me put up a more difficult one in front of you here. All right. What about this one here? Is it A, B, C, or D?
C.
How did you come up with C?
Because we'd use 7 x to the power 4 as a reference because that's the highest exponent.
Okay, I agree. So isn't that an even power though? Even degree?
Oh yeah, the degree would be even, sorry, so it'd be A.
It'd be A again. Yeah, and that's kind of the one where if you're looking at the beginning, you may not always see it. Okay, I think you've got that down. It's again like let me make a few adjustments to 17 to give you a new thing here. So let's say it's let's go negative. And let's say it's now B plus 1 as your exponent there.
Uh,
Which two answers are you down to?
it would be A or C, right?
That's correct. And so again, this power term of this leading term is there's really a one here. So it's x to the 1 times x to the b plus 1. And what you have to remember is when you're multiplying, you add the exponents. Okay. So to get negative down and down, this b plus 2 has to be even.
Okay.
So what does that mean for the value of b?
For the value of what?
Value of b. What does that mean for the value of b? B, if the whole thing is even, what values of b make this even? And sometimes it's good to just pick numbers. Like if b is, 1, does that work? If b is 2, does
2.
that work? Okay, so what kind of number is 2? Is it even or odd?
Even.
Even, okay. All right, you said you had another one on this list to look at.
18 and 19.
Okay. Which of the following equations is equivalent to 2 to the 5x equals 7? So what I have to do here is give you like a reference problem. So let's take something more simplistic. Like we know that 3 squared equals 9. Okay, which is true. So log base 3 of 9 equals 2. Okay, so let's look at the mapping. The mapping is this. Okay, this number comes here, this number comes there. Okay, so could you attempt to make the same mapping for this? We're not solving it quite yet, but just could you attempt to do that for me?
Um, I just didn't remember how to solve it, and I was like wondering if there's an easy way to remember.
There's no easy way to remember this. You have to have a reference. And that's all I'm trying to provide you here. Some sort of a reference so you know how to take these base exponent equals a value into a log. Like I'm asking you to give me what this is when you convert it to a log. It's currently in an exponential form. And I want it in logarithmic form, which is down here. And I'm just asking you to convert it. You don't have to solve, or we will solve, but it's not quite yet. In your problem,
A or no,
again,
B.
we're not solving. Like, don't worry about solving. I'm asking you, I'm asking you to write this as log, and then 3. What is represented by 3 in your problem?
2.
Okay, so base 2. Okay, and then what number comes here? Or thing? What goes here to the that you're taking the log of?
7.
Well, okay, equals.
Uh,
Why did we put 2 over here on the
5x.
right? Yes. Okay. That's all I was asking you to do. Because yes, like I know you can solve this, but if you can't write the equivalent logarithmic form, it doesn't matter. So one of the things you could do now that you've got this is you can kind of look at the answers and be like, do any of them kind of look like the answer? Well, no, no, and no. We don't even need to solve. Because that's the only one that's left over. Like this one, these two have log base 2, these are base 7, base 7. Those are bad. Now, in terms of solving it, you divide by 5 or you multiply by 1/5. And that's why it's like that. So what is really more important to me though here is that if I give you something like this, like 5 to the 4x equals 6, I want to know that you can rewrite this in logarithmic form.
It would be log 5, and then the main number
Okay,
would
so
be
yeah, log base 5, and then of is the thing you're
6.
of 6 equals
4x.
4x. Good. Okay. Very good. Okay. Now you could get a question where you have to go like we're going exponential to logarithm. You could be given a question where you've got to go the other direction. So I'll leave this one up here. But what if it's log base 2 of 13 equals 9x? Could you write this in exponential form?
It would be 2 to the power of 9x equals 13.
Yes. Now we're doing too many problems that are the same here. So let me kind of mix this up here a little bit. log base x of 4y equals 6. So this one's way harder because I've cleared the screen, but if you want me to, I can go back up and so you can see it, but I want you to write this into equivalent exponential form.
X to the power of 6 equals 4y.
Does this mean anything? I don't know. That is that is the answer. Any other questions of this type you would like, or do you want us to move on to 19?
We can move on.
Okay. So like most students, you're doing really well on the problems that are numerical, and the ones that are more symbolic, like most students, you're struggling. When I say most students, I just mean like a general, I'm not saying like lumping you in, but just a general thing here. Okay, so there's a couple of strategies for solving a problem like this. The first one is the direct method, which is where you just do the math. Second is you can try numbers. Okay, now you gotta be really, really careful when you try numbers. Okay, like, and even more so in this problem. When I say try numbers, like what a lot of students do is they'll put numbers in for x and for y. Well, you have to pick numbers that you can take the square root of, first of all. But like what most students do is they try numbers that don't work, like 0 and 0, 1 and 1. These are all bad, 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 bad. Never try these numbers. You have to get further away. So if you're going to try a number, unfortunately, you need to make like x. I'll just make x4 and like y9. Okay. But I'm not even sure that that will work. But that's what you would do if you were going to try numbers. So not only do you pick them away from 0 and 1, they have to like make sense of the problem. So you can take the square root of 4, you can take the square root of 9. You generally don't make them equal either. So that's another consideration here. That's your choice here. Which way do you see yourself doing something like this?
Probably the like direct method, but I feel like it wouldn't be easier.
All right, so direct method here requires you to remember that you multiply by the conjugate. And so that's the problem with the direct method. Like if you don't know how to do the direct method, yeah, it's bad. If you don't know what to do, I mean, you are left with only trying numbers. So on the bottom, it's a minus b, a plus b, and that always becomes a squared minus b squared. So that's another little thing here. Like the bottom, when you FOIL it, ends up being, this is just the bottom, it ends up being x minus y. The top is x minus y times the square root of x plus the square root of y, and these cancel. Look at that. And there's your answer, the square root of x plus the square root of y, letter C. Now, question is, would
Okay.
you have known to multiply by the conjugate?
Off the top of my head, I don't think so.
Right. And I agree. Like until someone tells you, I don't know how you know. I mean, it's like I call it a non-obvious thing to do because I mean, how would you know until someone tells you?
Mm-hmm.
Um, so it's like most riddles, until you know the answer, you're like, what's what's always what's always coming but never arrives.
Uh,
And the answer is tomorrow.
oh, okay.
Right. I mean, I don't know. How do you know that until someone tells you? Like
Yeah.
that's a tough thing. The number thing is good if you pick good numbers. And I don't know if you're gonna have a calculator or not, but you got to pick good numbers. 2 minus or 4 minus 9 over square root of 4, which is 2 minus 3, ends up giving you the same thing. The other thing is, if you're going to try numbers, you should try them the easy ones first. Like don't necessarily do it in order. Do it in the order where you feel like you can get it. The other thing is like this little thing like x is greater than 0, y is greater than 0. That's, make sure you choose numbers like that. Don't choose numbers that are not allowed by this. Um, So like, let me, I know you didn't ask for 14, but like, I want to make a small comment about this type of question. This is again, another test taking strategy is when you see answers and you see a square root, you have to be able to take the square root of whatever it is. So actually nicely, all of these work in here. These are all good, but you will sometimes see problems where they give you a number and you can't take the square root. I'm not talking about this. I'm talking about when you put it into the equation. Like you can only take the square root of 0, the square root of 1, or the square root of 4, the square root of 9, or so on, right? So
Mhm.
the question is like, should you try these? I think you should, but you should only try the ones that actually kind of work, that do work. You don't want to, if one of the answers is like 3, 5 times, well, that actually does work. Let's say 4. The square root of 5 times 4 plus 1 is the square root of 21. Well, that's bad because you don't know that.
Yeah.
So if you can't solve and you have to try numbers, that make sure that you can actually do it. And the square roots are kind of the one where you can maybe eliminate some solutions, but actually all these work. This first one becomes the square root of 1, this becomes the square root of 36, this becomes the square root of 144. The answer to this one actually is D, no solution though, but that's side point for that.
How did you get that?
So the only way to get to 3 when you're adding 9 is if this number is less than 0, but the range of square root of 5x plus 1 is always positive. Like this is always positive or 0. And the only way to get to 3 is if this were -6, there's no way to make this a negative number, so there is no solution.
Okay.
So kind of the analogous problem to that is like x squared plus 1 equals -2. When you square something, it's always positive. And if you're adding 1 to something that's already positive, this thing is always positive. So can it ever be a negative number? No. No solution.
Okay.
And these are standardized test things. They're not like stuff you're seeing in the classroom. Not tricks, they're just standardized test things. That like it's more important that you know I don't know, the characteristics than to actually know how to solve it.
Okay.
So, all right. Okay, there is a